Hi everyone. We'll be starting in 5 minutes. Let everyone else join. And today's session, I'm really excited about today's session. It's hacking with SQL. Uh, we'll talk more about what is SQL, why we need it, where is it used, all those things. But let's wait for a few more minutes. Let everyone join. Okay, let's get started. Okay. So before, like, without any further ado, let's start with SQL. Now, a quick question for everyone. If you could just type it in chat, how many of you, or can you tell me the full form of SQL? Anyone? Just type it in chat. Also, let me remove the banner. We are live. Full form of SQL, structured query language. Okay. Anyone else? Come on, come on. Okay. Very enthusiastic people. We have enthusiastic alien and Bish. I'm so sorry, Bish NUKT. Okay. We have okay, structured query language. Nice. That's good. That's good. That's awesome. That everyone here knows about SQL. Let's start with things that you would not know, maybe. Okay. So what is SQL? Now, SQL, let me also stop sharing because there's nothing there. We are going to so let me quickly give you a structure for this stream. The structure for this stream is that we are going to have theory kind of things at the start of the stream. Then we are going to move ahead. We'll do some practical examples. These would be very basic. So no need to be like, oh my God, how should I follow this? We'll go to a website where you are also allowed to code, where you can also enter your own queries, definitely. And in between, we will take a short 5-minute break so that we can gather ourselves for the hands-on coding part of it. Okay. So let me bring this up here. Let me remove the slides. And here we are. So SQL, structured query language. Okay. What is it? So it's kind of, you can say, a programming language, and it's more specifically a query language. It allows you to query things, specifically databases. It allows you to query databases. Now, which also solves the question of why do we need it to query databases? What is a database? Okay, what is a database? A very fundamental question. We talk about databases so many times. We talk so much about databases, but what is it? So databases can be thought of as a place where you store data. Anything can be a database. A Google Sheet can be a database, definitely. I am sure you must have all at some point used Google Sheets or even Microsoft Excel. And it also gives you those good APIs which allow you to query the sheets. Okay. So, database, it stores data. Now, someone in the chat pointed out it's a structured collection of data. Yes, there could be many ways to structure that collection. You could have it just like an Excel in form of columns and rows. Okay, in form of columns and rows. So that is one kind of structuring. You could also have it in a form of key value pairs, okay, where a key can be something unique which defines its values. Example, let's say you have a key which is called as ID, and its value, okay, it's a string or it's a number, it can be anything. Okay, so key value pair, that can also be a way of structuring data. Okay, so we have understood what is database, we have understood what we have not understood, but we have started with what is SQL. Now, normally, SQL, okay, structured query language, is used to query most of the times RDBMS. Yeah, so relational database, okay, management system in a way. But it's normally used to query relational databases where there are relations between the data that you have and other forms of data. Which relation am I talking about? There's a relation between the columns or the relation between the rows. So when you define a column of data, you have, let's say, a column which has the heading. So visualize Excel. Okay, actually, let's also share Excel here. Let's share Google Sheets here, and we can then work together on that. Let me. Okay, perfect. So you should now be looking at my Google Sheets here. So what do we have? We have three columns right now. Okay. ID could be anything. Let's go with the standard 1, 2, 3. Your first name, it could be A, and your ABC, let's say, and your last name is XYZ, and then QWE, RDY, ASD, FGH. Okay. So this is one way to structure the data, definitely. And you can also visualize it in form of key value pair, where key is the ID and value is one. First name is the key and value is ABC. Last name is the key here and the value is XYZ. Okay, that ways. So that's how we are structuring the data. And normally a SQL like syntax is, or the SQL actually, it's used to query a relational database. Now SQL is something that we have always heard of. SQL is something that we have kind of grown with, but SQL is not the only structured query language to query a database. uh, Could anyone quickly talk about what are other different types of SQL languages that they know, or SQL similar languages that they know? MySQL. Okay, more. Come on. Okay, so MySQL. Okay, you must have maybe heard of SQLite, and there is PostgreSQL. There's SQL Server by Microsoft. All these are more or less a database management system. Okay, MySQL database, SQLite database, uh, Postgres database. Okay, and to query it, you have PostgreSQL as a language, you have SQL Server as a database, and then you have a flavor of SQL as SQL Server language. So yeah, it kind of goes hand in hand. So those are things. But when it had initially, not initially, let's talk about the current. There are other query languages that you know of, but you may not recall it right now. One of them is GraphQL, the graph query language by Meta. Okay, so what is it? It is another type of query language. We'll talk about one or two things about GraphQL. If you I'm sure, if not if I'm sure you have used GitHub. So GitHub is has its own query language, a code QL. Okay, so it uses your code as data, and it finds any issues or potential vulnerabilities in your code. Okay, so sometimes you get this notification from GitHub which says, uh, this dependency, the depend about alerts that we call it. What does it do? It actually scans your code. It takes your code as data in a database, it queries your code, and it finds issues in that code. So that is code QL. Let me write down these names here. So we have GraphQL, we have code QL as a code query language. There is, now before we go move on to the next one, we have SQL like database, which are relational database. There is a relation the way you see it here. Similarly, you have NoSQL database. A very popular NoSQL document based document DB would be MongoDB. Okay, MongoDB, let me just write the name here. This is a NoSQL database, which basically means the things are not in tables, they are in the key value pair that we were talking about. Okay, they are in a key value pair of things. So those are NoSQL database. You also have a language called as AQL. AQL is Arango query language. Now, a very funny thing, it's a SQL like syntax to query a NoSQL database, ArangoDB. This database is NoSQL database. Okay, it has key value pairs, so it does not have columns. But to query this, okay, to query this, we have AQL, which is similar to SQL. And AQL, the full form of AQL is Arango Query Language. Also, I think this font is very small. Let me actually increase the font size of everything that we have. This should be visible now. Okay. Then at one point, like till 2019, we had another SQL like syntax. We will talk about what SQL like syntax looks like, but just to give you some fun facts here, we used to have something called as YQL, which is Yahoo query language. You'll see a Wikipedia page about this. So Yahoo query language, but it retired in early 2019, I guess. So, but yeah, something like that used to also exist. Yahoo query language. Again, the syntax was very similar to SQL. Now I've been talking about similar to SQL syntax, similar to SQL syntax. What is SQL syntax? What does SQL syntax look like? We'll come to it. Just wait for it. Okay. So before we move on to the SQL like syntaxes, there are a few things that you need to keep in mind what a SQL, a structured query language, should allow or what it shouldn't allow. Okay. What it should allow, what it shouldn't allow. Now, I am going to keep everything there where we had it. I'm just going to increase the font size of this whole thing. And I'm going to scroll a bit down. Okay. Now, what makes a SQL like language? SQL like language. What makes a SQL as SQL? Number one thing, there are few uh, what should I say? There are few commands, there are few structures, of there are few categories a language should satisfy when when before it becomes a SQL like language. Okay. Now you could also say in a way that these categories of definitions, they are also part of the SQL syntaxes. Okay, so many words I'm using. Let's reiterate. There are few categories of things a SQL like language or a structured query language should satisfy before we call it, oh, this is SQL syntax. It should allow you to do some specific stuff. It should allow you to do some kind of data manipulation, some kind of data definition before we call it as SQL language. Now, what are these categories? Well, I kind of gave it away. One is called as DDL, one is called as DQL, then there is DML, there is DCL, and there is TCL. Huh. Well, the L stands for language. So we are sorted on that part of things. Now let's talk about what are these. Like I have written these short forms. What do they mean? So first is DDL, which is data definition language. I'm going to write it as lang because I'm lazy. But DDL, that is data definition language. What does it mean? What does it mean to be a data definition language? Well, data definition, as the name suggests, it should allow you to define the data. It should allow you to define your data. It should allow you to define the structure of your data, how it should be structured. It should allow you to have that database in a way. Okay. So, and this deals with the CRUD operations, but not the read. So the CUD of operations and except the read. So CRUD stands for create, read, update, delete. Okay. So a data definition part of the language, this should allow you to perform the create, it should allow you to perform update, it should allow you to perform delete. It is not, the data definition language doesn't deal with the read aspect of the data. Okay. Now, when we come to SQL, now let's talk about the SQL syntaxes also in this whole line. So we have DDL. If a query language allows you to define the data, it has this category of data definition, then it is called as SQL like syntaxes. In SQL, the keywords which allow you to define the, have this data definition, they are actually create first. Okay. You could also say alter, oops, alter, and there's drop. There are many more actually, but we'll not deal with them. But this syntax, and this syntax, the create, alter, and drop, these three syntaxes in SQL allow you to first create a database or create a table or create an index. The alter, it allows you to change, okay, change the structure of the table. Okay. And the drop, as the name suggests, it deletes the database. It deletes the database. So create, alter, drop, there are other things also which come as part of the data definition of the language. One is truncate, then there's comment, then there's rename, but we'll not talk about that. Let's keep it kind of basic here. So data definition, the keywords are create. Okay. Create can allow you to create a database, it can allow you to create a table. What is database, what is table, we'll talk about it. Alter, it should allow you to change the structure of your database, it should allow you to change the structure of your table. Drop, it allows, or it should allow you to drop the table, drop the database. And these three are also the keywords in SQL. Now let's come to DQL, that is data query language. Okay. So the DQL part of the SQL, DQL part of SQL, what it does or what it should do, it should allow you to query a data. Now you can think of it as the read, like from a read perspective, it should allow you to read some form the data that you have. Now the keyword for it in SQL would be select. Okay. So DQL, it has only one keyword, and the idea is it should allow you to do the read part of the CRUD operations, and the keyword to use for it is select. When we start with our hands-on coding part of it, you will see that we are using select n number of times. That is the major thing that you should be allowed. Now let's come to the DML part of things, that is data manipulation. The data manipulation, a SQL language, a SQL like language should allow you to do data manipulation, which basically means it should allow you to again kind of update or modify the data. Okay. But this would be with respect to the data present in the database. When we talked about the alter, okay, we were actually changing the whole of the table, we were changing the whole structure of the database. But when we talk about data manipulation, we are exactly talking about the data inside the table. So if we go to our this table, okay, think of this as a table which has three columns: ID, first name, and last name. When we talk about data definition, we will add a new column. Okay, we'll add a new column of address that would be part of the data definition. or we'll rename this column, okay, from last name to last name me. Okay, that would be part of the data definition. But when we talk about data manipulation, we are going to change the value. So ABC now changed their name to JKL. Okay, QWE maybe change their name to QWER. So that is the data manipulation part of the language. I hope that was clear and understood. So what are the keywords in our data manipulation part of the language? One keyword is insert, that is adding new data in the table. So insert will allow us to, let's say, add a new data, a new row. Okay, so a new row, their name is UIO, and last name is PJB. I don't know, like just some random things. Okay, so these, that is the insert part of the data manipulation. What other keywords are there? Update. We just performed an update where we changed the name of QWE to QWER, where we changed the name of ABC to JKL. That is the update part of the data. Then we have delete. Okay, now understand the difference between drop and delete. A drop will destroy. Okay, a drop will destroy your database. It will drop your whole tables. But a delete will only delete maybe a row of data. So that is the difference between drop and delete. And that should also again reiterate the difference between changing the database or the table as opposed to changing the data inside the table. Okay, so we have insert, update, delete. There are other things again, like lock is there, and I think there's a call, but we'll not talk about it right now. Okay, so three things which allow you to manipulate. Now let's come to the data control part of the language, that is DCL. Now data control, how would you define data control? Well, it's fairly simple to understand. The word keyword says it all. Control the data, control the permissions, who should be allowed to do what. Again, like let's talk about a company. If you are working in a company and a company has like n number of databases, okay, most of the times, if it's a small company, you will have, let's say, two databases. Not everyone should be allowed to insert data, not everyone should be allowed to update data, not everyone should be allowed to delete data. There should be permissions of who's allowed to do what. These are also, so there would be a person who would be, let's say, a database admin. They have all the permissions, the admin permissions. Okay, and then you would have users or the employees who would have some select permissions. So the keywords here are grant and revoke. Okay, so grant specific permissions or revoke or take away the user access privileges, okay, that you had previously given. We'll again not do any coding, hands-on coding with grant and revoke, but you definitely understand this aspect of it, that you grant permissions to people, that okay, you, this user has the rights to uh, update and delete, and this user has rights to only read the data. Okay, only perform the select queries. And then you have the transaction control language, TCL. Now, this is, while very important, it's also very difficult to wrap your head around. So, I'll try to simplify it as much as possible. But if it, if it just goes above, or if you are thinking like, okay, I'm not able to wrap my head around it, that's fine. That's completely okay, because it took me a lot of time to really understand what this transaction of the data means. So a very famous example to think about transaction would be, let's create a table. So there's a table which has this ID column, and it has the user name column, and it has the account balance column. Okay. ID, let's go with 1 2 3. Username ABCDEFGHI, and account balance is, let's say, $10, $20, and $30. Okay, simple, a very simple table, very simple way to do the transaction. Now, where is this database being used? Why is it on the? Let's bring it here. Okay. So where is this current table, or where is this data table being used? Let's think about it. This will be used in a bank. Very simple. Okay, it will be used in a bank, and in the bank they are, just checking. They're keeping a track of the balance that you have in account. Now, one fine morning, A decides. Okay, A decides. Okay, I have like, wait. Let me just cut it from here, paste it here, so that we have more space on this side of things. So A decides that they want to remove $5 from their account. Okay, they want to remove $5 from their account. So let's say that they want to minus $5 from their account, which basically means that they will be left with, oops, $5. Oh, oops. Okay. Now, while this was happening, while ABC was trying to remove this $5 from their account, someone else, maybe wife of ABC, let's call her JKL. Okay. So, wife of ABC, JKL, was also trying to remove $5 at the exact same time. Okay. At the exact same time, JKL was also trying to remove $5 from ABC's account. Now, when ABC did this transaction of removing $5, ABC is assuming that now I should have $5 pending in my account. But at the same time, JKL also tried to remove $5. So the final balance in ABC's account should be now $0. Okay. So two people trying to remove $5 from a $10 account. At the end, the balance should be zero. But what if when ABC was trying to remove, suddenly there was a power cut and the ATM machine just, let's say, stopped due to some fault, due to some error or something. The $5 were not removed. Okay. So when ABC was trying to remove $5, there was a power cut, or or let's say there was a machine failure, and ABC was not able to remove. So how much money is still left in ABC's account? $10. Now JKL was also trying to remove 5. Okay. So JKL was successful in removing $5. So now the final balance in the account should be $5. Okay. If both the transactions would have been successful, the final balance would have been zero. But since one transaction failed, the data was rolled back to 10. And when JKL was trying to remove it, the final balance was 5. I gave you two keywords here. One is rolling back, And the second keyword, not a keyword, I talked about transaction. Okay. And when this operation is successful, when this operation has executed, you could call it as committing a transaction. So one is commit, that is the operation is successful. You remove the money, you change the data in the database, you change the data in the table. Sorry, more like you change the data in the table, you committed that transaction. And if due to some reason the transaction was not successful, you would roll back, okay, transaction. So these are two keywords. If things are successful, you do a commit. If things uh, just fail at some point, you do a rollback. And in a database, before you actually remove money, before you start removing money, you need to first check the balance. You need to lock a balance. Okay, lock. That was one of the keywords which we missed at data manipulation part of things. Okay, I said we will talk about it later, or maybe not talk about it. But yeah, whenever transaction is happening, okay, a transaction is happening, you lock that particular row, you lock that particular row, allow one transaction to be either successful or fail. Okay, there's nothing in between. You either allow it to get successful or you allow it to fail. Until that time you have locked that particular row. And once the transaction is successful, you commit. Okay, you save it, you save the new change in your table. Or if the transaction is unsuccessful, you roll back to the previous save or the previous data that you had. And then you also do a unlock. Okay, and you allow others to now change that particular row. And that, my friends, is how a transaction works. You commit, you roll back. There are two more keywords here. There is, I think, a save point. There is also one more, I think, something with related to transaction, but not talking about it. But I hope you understood this part of the things. You in a transaction, now transaction can be anything, actually. It does not need to be definitely related to money, and definitely related to account balances and banks. A transaction can be anything. Updating a username, let's say you are logged in two different accounts in two different let's say you are logged into your one single Gmail account in two different laptops, and in both the laptops you are trying to update the password of the Gmail account. Well, if both sides are successful, what is the last safe password in your table? You would never know. So that is when you lock that particular row. Let the password, let the person update the password once, then you commit it. And let's say if they were not successful, there was an internet failure, then you would roll back to the previous password that was already there. And then you'd allow the second person to change the password. You'll unlock that row, allow the second person to change the password. I hope that gave you some idea about what a SQL like language should allow. It should allow data definition, it should allow data querying, it should allow data manipulation, it should allow data controlling, it should allow a transaction controlling. And the keywords are here. Okay, the keywords that is used fairly everywhere with some changes here and there. So my SQL will use keywords like this exact keywords. SQL server may have a slightly different keyword. Okay, uh like instead of create, I think there is use schema. Not use schema, I think something similar to that. And the select, I think that is fairly universal. But yeah, there would be some changes here and there. Some keywords would change here and there, but the overall picture remains the same. These are the things that a SQL like language should allow, okay, or it should not allow, like it should allow, sorry. I'll take a quick pause here. I've been talking for too long. Let's see any questions with regards to everything that we saw until now. I'll wait for a few here. Reminded me of synchronization chapter in OS, that is operating system, I'm guessing, where we learned about mutex. Mutex. Interesting. If you think about mutex, that would be actually a part of your OS locking and unlocking. It could also be, mutex could also be a part of your Java code actually, where you allow it to lock particular functions, let the functions complete, and then unlock it. I think mutex is one way to lock and unlock, more like. Yeah, mutex would definitely be a one way to lock and unlock specific parts of transactions, but there are many other ways to lock and unlock. Yeah. Okay, any questions? Okay, none. That's nice. So remember when we wrote this GraphQL, and now to add to it, so GraphQL is Graph Query Language by Meta. It's not specifically designed for graph databases. Okay, you can think of it as DQL and DML for APIs. Okay, so GraphQL is more of a DQL, that is a data query language and data manipulation language for APIs. Okay, so that is one additional thing that I wanted to add for GraphQL, but I did not want to use some keywords which you wouldn't understand. Okay, so nice. No more questions. We'll take a quick, actually, not a quick, let's take 8 minutes break. Let's breathe in and breathe out, stretch our legs, and we'll be back. Okay, we'll be back at exactly 12:50, like 12:50 for me, 8 minutes basically. uh Back in 7 minutes, let me write that. And then we'll start with some more parts of SQL and the hands-on coding, and then we'll end it. Hello. Okay, let's be back. Hey, hey, hey. Let's start again. Okay. Let me wait for a minute. Let maybe others join and we'll start. Okay. Okay. Now let's start with the next part of this session, that is writing actual code. Okay. But before that, let me do a bit more theory and then we'll move towards the actual code part of it. So we saw so many things. Let me delete some unwanted stuff from here. Don't really need this. Don't really need this. Okay. Actually, we just delete all these rows and we are just left with these things. We don't need this part of it, definitely not for now. And okay, so this is what we are left with. Okay, now a question that I just thought, not a question, a thing that I thought of, like I have been talking about databases and tables for so long, I actually forgot to tell you what exactly would be a database, what exactly would be a table in a database. So think of this whole workbook, this Google Sheets workbook, as the database, and every sheet in the database as a table. Okay, so sheet 1 can be one table, sheet 2 can be another table, sheet 3 can be another table, all those things. Okay, so those could be called as your tables in a database. Okay, I've added so many tables right now. So these things can be called as the tables in a database. Right now, these are sheets in a workbook, but in a database sense, a database can be a collection of multiple tables. That's as simple as that. Okay, now let's come back to our original or the sheet 1 or the first table, and we'll talk about one important aspect of any database or any relational database is normalization, normal forms. I'm sure you must have heard of these terms. I'm sure you must have heard of uh, this normalization word, 1NF, 2NF, 3NF. But what do they actually mean? So again, this is for people who don't really know about it. So these are the terms. There is 1NF, there is 2NF, there is 3NF, then there is 3.5NF actually. And the 3.5NF, it's also known as BCNF, I think. Yeah. Then you have 4NF, there is 5NF, there is 6NF. Okay. 4NF, 5NF, 6NF is something that is not really required in practical sense of things. Okay, once you start building your own tables, once you start adding your own tables, once you start building your own databases, you'll realize these things exist but they don't really mean anything. Example, in for MySQL specifically, 6NF is still a theory. It has never been practical, it's still being discussed. Okay, now, what is this NF? So, NF means normal form also sometimes called as normalization. Okay, so 1NF is first normal form, 2NF is second normal form, then you have 3NF, that is third normal form, then you have 3.5NF, which is also called as uh, BCNF, that is Boyce Chord normal form. Okay, and then we can ignore the rest of it. So they exist, but we don't really need it. So let's remove them from picture. So what is this normal form? Let's talk about them with an example. Okay, what examples can we think of? Let me also see my notes, of course. Hmm. Okay, let's talk about from the perspective of MLH. Okay, Major League Hacking. Now let's go with mm, salutation, full name, university name, and what all do we have? We have those uh, tags. Okay, tags on Discord. I don't know what they are called specifically, but we'll tell them that these are tags. So salutation can be, let's say, Mr. And full name can be, let's think about random name generator. Random name generators. I am going to just do a random name generator and quickly fill this out. So the first name that I got was Kath Tony. Okay, then let's do another one. I'm sorry, I'm taking too long here, but let's. And all these came from random name generators. Okay, so we have these names. Let's say everyone goes to a particular university, not a particular university. Let's say all of them are students. So ABC University, ABC University, DEF University, GHI University, JKL University, and tags on Discord. These are, let's say, you have been part of multiple hackathons. So we'll talk it hackathon 1, comma, hackathon 2. These are the two tags that they have. This person has also been to the same hackathon. This person has also been to the same hackathon. This person has been to hackathon 1 and hackathon 3. This person has been to hackathon 2. Okay. Now this is the current structure that we have with respect to on a Google Sheet. Okay, now let's convert this to a table in a database. So we have Mr. Garth Tony, who is in ABC University and has participated in Hackathon 1 and Hackathon 2. Now, let's talk about the first normal form, the 1NF. So the idea behind 1NF is that each table cell, okay, think of this as a cell, each table cell needs to have a single value, so commas not allowed. Secondly, each record needs to be unique. Okay, each record needs to be unique, which kind of brings me to a different format. So let's take the first one. I think we have too many people here, but okay, we'll stop. So now we are talking about the 1NF. So after 1NF, what do we have? Okay, let's also take this and let's put it here. So Mr. Tony, ABC University has been part of two hackathons. So hackathon 1, and we'll repeat this, and here we'll put hackathon 2. Similarly with Miss Tina Matthew, we'll put it and we'll take out this. So no duplicates. That's the first idea. Okay. And similarly for Mr. Tom Matthew, and again this would be repeated. I think I should remove one or two of them just so that you don't see me copy pasting so many things so many times. Sorry Tom, bye bye. Okay, so we have Elizabeth Parker, who has been part of these hackathons, and then we have thanks Una being for participating in only one hackathon right now. Okay, so this is after 1NF. Okay, idea is that each uh, row in a table, okay, or each cell in a table should have only one value. Even though we have repetitions right now, we'll talk about it later. So this is after 1NF. Now, before we move on to the next parts of things, we need to understand one important aspect or one important property of any table or in a database, is that it should have something unique in it. Right now there's nothing unique which separates out these rows. Okay, example, what I mean by that is the problem will come is, okay, tell me what's the row number of Garth Tony, and then we'll have well, actually there are two rows for Tony. Okay, for Garth Tony, which one should I point you to towards? And that's when the confusion will start. That's when you will not be able to properly manipulate data or properly query a data. Okay, so that is why we need to have something unique in a database. Now normally your databases or your tables have some uniqueness to it, but if they don't, you can add some uniqueness to it. A very simple idea would be to add a row with id, which with each id being very unique. Okay, you don't have repetitions. So let's do that. Actually, let's add a new column. Oops, what did I do? Oops. I did say one column. Oh, right and left. Sorry. I have a right and left problem. So let's add a new column here. And that is an ID. So every row will have a unique ID. Okay. Now, if you want to query the table, you will say, okay, tell me where is Garth Tony. It will return you, okay, it's in row 1 and row 2. Which one do you want to manipulate or change if you want to? and then you will say, okay, I want to change the one in row 2. Okay, done, sorted. So this key or this new row needs to be unique, and it is also called as the primary key. Now, there is an option where you can have something called as a composite key. A composite key can be a mixture of two things or two or more uh, things in a table, and together they should be unique. Together they should be unique. So in this table, what do you think, what are the two columns that we can take which are going to together say that okay, this particular row is unique, it is not going to be repeated? Remember the columns. Let's forget about the id, forget about the id part of things. If I don't know how, I was going to keep my hand on screen and say hide it, but yeah, forget about the highlighted part. But if you only have this table, which two columns would you select to form a composite key? Or maybe which two or three columns? Come on, in chat right now, tell me, which two or three columns would you select, or four columns would you select to form a composite key? Together, when we talk, bring them together, it should be unique. That's the whole idea behind a composite key. Anyone would like to take a guess, take a try? Just tell me like which two columns together. So salutation plus full name, or full name plus university name, salutation plus university name, whatever, whatever. What do you think, which two columns, if we take and join them together in a way, would be unique, would be a primary key, would be sorry, a composite key? Come on, there are like, it's okay if you are taking a wrong guess. ID plus full name, but we have hidden the ID column. So assume that the ID column does not exist. Then which two? Full name plus university, name plus tag, name plus tag. And full name plus university. Full name plus university, Garth Tony with university wouldn't be unique. Full name plus tag, yeah, that's right. So why not full name plus university? Let me tell you. So Gar Tony plus EBC, if we take them together, the next row again has that same thing as the key. So there is going to be a duplication. But full name plus tag together is unique. So Gar Tony and Hackathon 1, Garth Tony Hackathon 2, Tina Matthew Hackathon 1. So Tina Matthew Hackathon 1 can be a composite key, and together they are unique in this particular table. Okay, in this particular table they are unique. Okay, there will never be another row with these two values similar or same or exactly same. So yeah, you get the idea of primary key, you get the idea of composite key. Now let's move towards the 2NF part of it, the second normal form. Now, in second normal form, the idea is that firstly, whatever you have, whatever table you have, it should first be in first normal form. Okay, it should be in 1NF first, and then you make the 2NF part of it. Okay, so that is rule number one. Be in 1NF, then you move towards 2NF. Rule number two, a single column primary key functionality, or should okay, a single column primary key should not depend on something else. Okay, what do I mean by that? uh, uh, um okay, let me think of something. Hmm, let me quickly look through my notes. Where can I explain it in a better manner? Okay, so as per my notes, one way you could visualize it is, or let's think about it from this perspective. You would need to have, maybe or maybe not, you need to remove the duplication. Okay, let's put it as that simple. Remove the duplication as much as you can, in a way. And for removing duplication, you cannot first bring them into same, like, uh, adjust them with the commas, okay, or put two values in the same cell. That is not allowed. Okay, so how would you remove duplication? So let's first search where do we have duplication. So there is a duplication in university names. Why? Because Garth Tony went to ABC, Tina Matthew also went to ABC. Okay, we are not talking about the duplication in names because we created that duplication. So let's actually go to this part of the table. So university name, that is something that is duplicate. Okay, secondly, the tags on Discord, the hackathon names that they went to, that is kind of also duplicate. So there are many people who went to hackathon 1, there are many who went to hackathon 2, there's one who went to hackathon 3. So there are like two places where we have duplication. This was not duplicated until and unless we created this fun and a form of it. So that's why full name is not duplicated. What else is duplicated? I think salutation also has some parts of duplication to it. Okay, so there is Mr., there are two Miss, and there's one Mrs. So I think there is, so you can now see that what are the things that are kind of duplicated across. Now, in 2NF, we are going to segregate this duplication, and that is not going to be possible until and unless we partition the table. Okay, so partitioning the table, so let's first bring in our id column. Actually, let's bring in our whole of database here first in our 2NF form. Now let's create a separate database with university name. Sorry, not a database, separate table with university name. And we have three universities: ABC, GHI, JKL. Okay, ABC, GHI, JKL. These are the only three university names that we have. We can give them a different ID, a uni ID, uni ID 1, let's say uni ID A, uni ID B, uni ID C. These are the three uni IDs. Now our this table will change from ABC, 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 GHI, GHI, JKL to ABC. Oops, this would be, sorry, A, 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 and GHI has the key of B, B, and JKL has the key of C. Okay, still have duplication. We'll come to it. Wait for it. So now we have created a separate table with university name, and we have assigned it three new IDs of A, B, C, and that is what we have replaced this column with. Now replacing this column with these ID, this is called as a foreign key. This idea is called as having a foreign key in your table. okay, because this is a different table. Okay, this is a different table, and we are taking these keys from here, adding them here, and that forms the basis of a foreign key. Similarly, let's create another table for our hackathon. So let's call it as hack id, and let's call it as, like, this is your tags on Discord. How many hackathons did we have? Hackathon 1, hackathon 2, and hackathon 3. Okay, and we'll have this h1, h2, h3. Place this h1, h2, h1, h2, h1, h2, oh sorry, h3 I think, and then h2. Okay, now we have this, but still the duplication does not go away. We have just reduced the names. Okay, we have reduced the full form to short form. Okay, and how many tables do we have now? We created one table for university name. We have created one table for our tags on Discord, and we still have the original table. Now let's see, can we reduce this to more, like, can we simplify it more? Think about it. How can we simplify it more? Should we create another table which has this salutation part of it? Can we do it? Can we have that aspect to it? Let's try it out. Let's try it out together. We may, or we may have to delete it. I don't know if how many of you came to my yesterday's uh, session where we were talking about agile, and you should have that courage to write something and then delete something. Let's call it as SID, that is salutation ID, and we have salutation here. Let's have salutation S1, S2, S3, and let's have it as Mr., Miss, Mrs. And let's rename this to Mr. is S1, S1, Miss is S2, S2, Mrs. is S3, S3, and S2. Okay, again we have shortened it. We have a short form here, but we have still not changed the table. What can we do more? So now if you observe here, S1 Gadstoni University name. Okay, do you see something here? Can we take this out and replace it with just one ID maybe? So can we have another table? Let's do it on this side. New ID, which takes in full name and university name. And can we have a new ID of new one, and full name is Gath. Oops, let's copy it from here. And university name is going to be A. And then we just eliminate this part of it. Okay, let's not eliminate, let's color it out. So these two together have gone to this one row. Okay, can we do similarly for this? I guess yes. Let's do it. Sorry. So Tina Matthew goes from there to here. And what else can we segregate? So let's give them a new ID of new 2. And which university did they go to? They also went to A. Okay. Then we have segregated this out. Let's color them again. Now, similarly for this, can we have a new 3? And Elizabeth Parker goes here, and university name is B, and we have new 4, and that is this person here who went to C. Okay, we still have some duplication here. No problem. If we remove this part, this whole part of it, okay, if we actually remove this column from here, let's say we have one table, this whole table without any duplication, right? Now let's come to this table, uni id, university name. This does not have any duplication here. Okay, but there is a problem. How do we connect this university with this person here? How do we do that? We might need that column that we just deleted. We would have to, unless you come up with something. Similarly, we still have this new thing here, which is not connected anywhere here. How do we know this person has what salutation? We still have to connect our hack ID with this whole thing here. Interesting. How do we connect? How do we connect this and this and this with this? Can we or can we not? Let's wait for a few of you to think about it. Let me color those things out. So we have this table, we have this table, we have this table, and we have this particular table. Okay, these are the four tables. We segregated out the data. Let's say we don't have this column actually for now. Okay, and ignore this column for now. Let's color it, let's say black. Okay, you have these four new small tables with no duplication. How do you connect them together so that you have a final table with everything connected together? Everyone knows everything. How would you go about it? Let's take a moment to think about it. So let's revise. We had this data, but we had we cannot have multiple things in one table cell. We cannot have things separated by comma in one table cell in a relational database, in a SQL like database. Okay, or any database which supports SQL. We cannot have things separated by comma. That is why we did a first normal form and we segregated everything out. Okay, once we segregated everything out, we had this duplication, Mr. repeated, and then we had Miss once, twice, and thrice. We have Mrs. twice. The names got repeated because we segregated this out. The university names were repeated so many times. Okay, and the hackathon names were repeated so many times. University name repeated in the original DB itself. The hackathon names got repeated in from the original DB itself. The full names got repeated because we segregated things out. Okay, and we created four new tables where nothing is repeated. How do you connect each of them? So when I mean connect, how do you connect Garth Tony to salutation of Mr. to university name of ABC and to tags on Discord of Hackathon 1 and Hackathon 2. Okay, that is what we are thinking together. We are brainstorming together about it. How would you do it? And we are actually trying to achieve the second normal form here, but I think by the end of it, we would kind of achieve the third normal form too. Okay. Okay, enough time to think about it. Let's start with it. So, we'll actually let me copy this table. Now, when you want to achieve the second normal form or the third normal form, be wary that there would be some duplication. You cannot have very unique no duplication table. There would be some duplication at some point. You just need to identify what needs to be more unique. Okay, that's the whole idea. What needs to be more unique, and that's where you start from. Okay, so let's talk about Garth Tony. So Garth Tony should have the salutation of Mr. Okay, now there are multiple ways to do this. One way would be we could still have the salutation column. Also, let me change this to something which is not this dark. Let's change it to, I don't know. Do you think yellow would look good, or yellow would be visible, reasonably visible? Okay, I think it should be. Okay, so one thing is we could actually have the salutations for every person. So this would go back to Mr. Tina Matthew would go back to, let's say, I don't remember, sorry. Tina, Miss, and Mrs. and Miss. Mr., Miss, Mrs., oops, and Miss. Okay, this is one way definitely. Or we could have the SID here where we know this person is S1, Miss is S2, Mrs. is S3, and this is S2. Okay, just a short form for that. But a good I like this would be better. Why? Because if someday you want to change this from Miss MR to Mr., let's say, properly, then you only have to change in this particular table and it would be automatically updated here. Okay, it would be automatically reflected for this particular column or this particular ID. So again, this is a trade-off that you have to think, that will this someday change? Maybe, maybe not. It could go from this, the short form that we had, okay, to a full form that we will now have. Oops. So let's, again, as I said, you have to think about it. You have to think of the trade-off. So we could change it to this new, this SID. Now the full name, okay, it would still remain the same. Let's go with the university. Again, the name of university, well, it may change. You may have additional universities. So again, it makes sense to actually replace it with uni ID. So let's see who all went where. So Garth Tony went to ABC, which is A. Tina Matthew went to ABC, which is A again. Elizabeth Parker went to GHI. GHI is B. And I'm guessing Una Sally went to JKL, which is C. Again, think about it from the perspective. Will this change in future? Well, it may not. Does it make sense to have it with the IDs that we created? Yes. Okay, cool, done. Next, what else did we need to connect? We needed to connect them with the hackathons, the tags on Discord. And now, can we replace this tags on Discord? Again, we could actually have this whole thing, or we could replace it with just the hack IDs. So hack underscore ID. Okay. Now, Garth Tony went to how many hackathons? Well, Garth Tony went to two hackathons actually. Garth Tony went to hackathon 1 and hackathon 2, which would be H1 and H2. Now, where should I put H2? I cannot put it in the same cell. So, I may need to repeat this. Okay. I may need to repeat this. Let's say we may have to repeat it with, oops, this and then put H2. But hey, interesting. We have just shortened it, but we are coming back to our this first normal form. Bad idea. What should we do? Well, one thing could be that create a new table, take in this ID. Okay. So Garth Tony has the ID of 1, and ID of 1 and 2, both of them belong to the same person. Everything remains the same. The only thing that changed was the hackathons that they went to. Okay. So basically, ID 1 and 2 are depicting two different hackathons here. Everything else remains the same. So can we take this primary key and this and create a new table out of it? That's interesting. Let's think about it. So what we are going to do is we are going to take this ID column and take the hack ID column and create a new table out of it. Okay, create a separate table altogether. So we can take ID of 1 and the hack ID would be H1, and we can have, or the vice versa, can we have the hack ID 1, the hack ID as H1, and who all went to H1? Well, ID 1 went, and who all went to H2? ID 1 went to H2, and we had H3 who all went to H3. Interesting. Let's think about it. So now this is where some confusion starts, and let's come back to it. Think about it from this perspective. We have this ID and we have this hackathon. Hackathon 1, hackathon 2, hackathon 1, hackathon 2, hackathon 3. These are the only three hackathons. The only difference is who went to which hackathon. Okay, who went to which hackathon? Okay, so can we have H1, H2, H3, and we can just connect them with the IDs. H1, who went to H1? H1 was attended by one person, two person, and three. Okay, three people attended H1. What were their IDs? The IDs were 1, or we could create a ID with 1. We could create another ID. H1 was 3 and we have H1 with 5, but we already created a table with their full names. So let's take that. So let's take this new ID here, and H1 was attended by a new one, that is Garth Tony. H1 was also attended by new 2, and H1 was also attended by Elizabeth Parker, who is new 3. Okay, now let's talk about H2. H2 was attended by how many people? Again, Garth Tony attended H2, Tina Matthew attended H2, and Una Sally attended H2. Okay, so H2 was attended by new 1, H2 was attended by new 2, and H2 was attended by new 4. Where is this new coming from? This new is coming from this table. Okay, the table that we created with new ID, and their full names, just the full names. Okay, cool. Let's talk about H3. How many people attended H3? Where is this H1, H2, H3 coming from? It's coming from hack ID. Okay, come on, let's think about it. H3. H3, how many people attended H3? H3 was attended by just one person, Elizabeth Parker, whose ID is new3. Okay, so this is what we have right now. We have these people who attended these hackathons. Hmm, interesting. So this could be another table. Now, let's add a new ID to this column. Let's call it as final ID, and this would be F1, this would be F2, F3, F4, F5, F6, and F7. Okay, so many IDs. Okay, relax about it. Let's see what all have we done till now. So number one, we segregated out our table. We segregated it out. We pulled it out. We created a new table out of just the names. No duplication, nothing here. We pulled out the salutations that they had and made a new table out of it. No duplications, nothing. We created a new table just for the hackathon IDs with like hackathon 1, 2, and 3. No duplication again. We created a new table with the university part of it. No duplication again. And then we connected what all we connected? We connected the hackathon with the names. Okay. Using this helper table here, this final ID table that we created, where we are connecting final ID with hackathon ID and the new ID, which is the names. We have connected the hackathon and the name. And now we are creating this another table. Okay. Let's say where we are connecting what all? We are connecting the salutations. We are connecting their full name. But do we need to connect the full name now? Well, the full name already has a different table. So instead of that, we could call it as a new ID. Okay. Salutation was, let's say, Mr. Also, let me remove this all. So salutation was Mr. Uh, Salutation should go later, actually. So let's start here. New ID. So who's the person? The person is, let's say, Garth Tony. So new one. Let's have their SID. The salutation was Mr. So S1. And we have also have to connect them with their university. So let's say uni ID. And we also had to connect with their hackathon and their name. But can we do better? Can we, since we have already connected the hackathon and this, can we do better? Can we kind of connect them to something else? Can we connect them to something else which allows me to have less duplication of my data? Can we have that? Let's think about it. And also let's think about it quickly because I'm running out of time now. Hmm, interesting. So new one went to A and new two went to A again. Okay. And new 3 went to B and new 4 went to C with respect to the university here. Okay, let's call it uni 1, uni 1, and uni 2, and uni 3. So new 1 went to uni 1, new 2 went to uni 1, new 3 went to uni 2, new 4 went to uni 3. Okay, can we relate that? So new one went to, let's say, let's connect them with the university first. Uni 1, new 2 went to uni 1, new 3 went to uni 2, new 4 went to uni 3. Okay, we still have some duplication here, but I think that's okay. Let's talk about this SID. Mr. So that is S1. And what about new 2? What is their salutation? Miss. Okay, so that is S2. New 2 has salutation S2. New 3 has salutation S3. New 4 has salutation S2. Okay, we still have that. And now let's talk about Hack ID and which hackathons did they attend. So we have already kind of arranged that. Okay, we have arranged that. We know that new one went to H1 and new one also went to H2, that is F1 and F4. Was it a bad idea to segregate that? Think about it. Hmm. What could we have done so that we would have had a lesser thing here, a lesser connection here? So that is something that is very interesting. Can we stop the duplication? Not really here, not in this aspect. We will still have some duplications. We'll still have some form of duplication. So maybe just segregating out the tables and then reaching the first normal form, that is the only thing that we could do. Okay, so hack ID, new one went to H1. Okay, new one also went to H2, so maybe we'll have to duplicate this part here. Okay, and new 2 went to H1 and new 2 also went to H2. Oops, I confused myself here. Let me take this out from here and let me put it here. Oops. So we have this. Okay, so you get the idea. You will still have some duplication here. We will actually end up with only this part of it. So we will have, let's say, salutation of S1, S1, S2, S2, S3, S3, and S2 here. And we will have Garth Tony with the name of new one and new one, and then new 2 and new 2. We This person goes to new 3 and this person goes to new 3 again, and this is new 4. And similarly with the university names. Okay, so this would change to uni 1, uni 1, uni 1, and this would be uni 1 again. This would be uni 2, this would be uni 2, and this would be uni 3. And similarly for hackathons. Okay, so that would be H1, H2, H1, H2, H1, H3, and H2. So we end up with kind of this whole table only. The only difference is we have segregated out the data into different tables. So at any point, so this is the final relationship table that we will have, which was something that we already made in our 1NF, and we repeated it in our 2NF and 3NF. The only difference was we kind of segregated out the data. And now, at any point, if you want to add a new person, you will add a new person here. If you want to add a new university, you can add to just university. If you want to add a new hackathon, you can add it to just hackathon. If you want to add a new salutation or change any salutation from the short form to full form, you'll do it here. And this is the way you would still have relationship between them. And that was something that I was, trying to come to at the end of it. Think about it. Okay, we would be able to segregate out the data, not have duplications, but at the end of it, to have the relation, we still would go back to our 1NF. And this is something that is, that is something that you'll observe always. You could think of it. So this table that we created, nah, not really needed. And that is the courage that you should have to remove your code, delete your code. Okay, and that kind of brings me to the end of our first normal, second normal, third normal form. The 3.5 NF, that is a cleanup or more cleanup on 3NF if there are duplications. If you think, now that is more of a thinking part of things. Think about it, that okay, maybe I am not really going to need this salutation table ever again. Once we create, we'll have only these three salutations, nothing else. You don't really need to create this table. Then you will add it to your this column only as Mr., Miss, Mrs. Okay, so that 3.5 NF is more of your perspective or your requirements, okay, that you need. But names, this is something that is going to add. Hackathons is going to be added more and more. Uni name, this is going to be added more and more. Salutation, not so much. So that comes part of 3NF. Just to quickly repeat, and I'll give you a website actually to learn the queries, and maybe we'll do one or two queries. What did we do? We started with what is SQL. We started with what forms a SQL language. These are the things that it should form. Then we went towards normalizing data. When we had a database like this with each table having some repeated data, we wanted to move away from repeated data. Then we created the 1NF part of it, that is first normal form. In first normal form, we broke the cells into individual rows, so that there is no comma separated value in any cell. So once we broke it in this format, we went towards the 2NF part of it, where we wanted to break it out further so that there is less duplication in this whole part. So we created a new table with just the full names. We created a new table with university. We created a new table with hackathons and Discord IDs. And we created a new table with salutation. Now that would have been part of our 2NF, breaking out things. And then we had to connect it back together and have less duplication. So 2NF and 3NF. Okay, so to bring it together again, we would still have duplication. And that is something that we observed. We brainstormed about it. We thought about it, that can we have it less as possible, but sadly not in the database structure that we had, the data that we had. So that's why we ended up with this. But now the best part is that anytime you want to, let's say, add a new data, add a full name, you could only query or add into this database without hurting the whole of it. If you want to add just the tag, you could only query this table without hurting or querying the whole of it. If you want to add a new university, again here. And now that everything is connected with new IDs, changing a full name will not require you to change it at two places. Changing it only this table, this full names table, will make sure that it's changed everywhere else. And we also talked about 3.5 NF, where it is the decisions that you take, the decisions that you make. When you, like, do you really need uh, to have a separate salutations table? Do you want to make sure that, or do you know that it's not going to get repeated ever again? So these are the things that we talked about. Okay, hopefully that was an interesting session. I know I took too much of time to build it, but that was the whole idea, thinking about it, and coming back to what you have. And now I am going to show you something interesting to, sorry, yeah. So there is this website sqlbolt.com. I will share it in chat also. So sqlbolt, this uh, more or less teaches you the DML part of our query, that is data manipulation, writing select commands, the select keyword that we saw in, sorry, in DQL. Okay, the data query, in that we saw one single keyword of select. You can learn more about it on this particular website. Let's quickly go to this website. Okay, select queries 101. You can read about what it is, you can see some examples, and there are exercises. So let's actually solve one or two exercises very quickly, just so that you get a hand for it. Okay, you get a hang of it. So, and here you, what, how do you navigate through this? So this is the question here. So you will learn more once you learn more about the SQL select command, then you will solve these questions. So here the first question is, find the title of each film. So there is this table, it's called as a movies table. It has ID, it has title, it has director, it has year, and it has length in minutes. Now you would observe that director, it's repeated so many times. The whole thing that we talked about right now. You cannot have tables without some duplication. There are years here, the length in minutes. Definitely it will repeat for some film or the other, some movie or the other. So now, how do you write select queries? So you do a select, that is one query that we wrote. What do we want to find? We want to find the title of each film. So when you talk about each, okay, each is all. Okay, so we are talking about how do we return all data. We return all data by doing a star. So select star. Where do we select it from? Okay, we select everything, we select all, but from where? So we do a from. And then we also do a movie, like which table do we want to select it from? We want to select it from movies, and everything ends with a semicolon. So this is a MySQL syntax. Now this automatically runs. Now we selected all from movies, so we got everything, but we only want the title, which basically means instead of selecting all, we need to select the title from the whole of movies. So we got all the titles. Okay, and we solved the first one. There's a tick mark. Next question, find the director of each film. Find what? The way we found title, we have to find the director. So let's change this. Let's first see the whole table. We have IDs, which is unique. We have titles, which is unique with some additions to it. We have directors, which is not unique. And okay, we have a director. So we just need to replace this with director. And that's all the second one. Now, the third question, find the title and director of each film. We found the title initially, we found the director initially. How do we find both of them? We do a title, comma, director, and we found that. Next is find the title and year of each film. So, title and year of each film, and we solved that too. And then we have to find all information about each film. That's very simple. That's what we started from. Star. Okay, so all is basically means star. You could also actually do ID comma title comma director comma year comma length underscore minutes, and even that would return everything. But this is fairly very tedious. So this solves your question problem. Okay, so that is something that I gave you. You can learn more about all the data query parts of it. So the syntax is select, but you can merge your select syntax with many other things, and you can learn more about it on this particular website. Let me just highlight it again. It's called as sqlbolt.com. You can learn more about it there. Our session was more about the theory. I did not move more towards the practical aspect of things, the practical queries. And hopefully in next session maybe we will talk more about the practical aspects. We'll talk more about the queries. How do you query a DB? What all things do you do with the... But till that time, you could learn more from sqlbowl.com. So that is my time. Now I am going to pause here for 2 minutes. Do you have any questions? Anyone, any questions? Cool website. Yeah, I know. It's a really good website. Anyone else, any questions? Okay, seems like everything went well. Again, the idea was to tell you more about the theory behind SQL. We are still pending on some parts of it, like set. Okay, sets and unions, these form the whole idea behind database. That is a very cool topic. So at any point you want to research, do research about how databases are nothing but related to but the sets. Okay, so set has a union, it has uh, how you define a set of things, how you define a set of numbers, set of integers, all those things. There's so many things. And there is a different mathematical area called as set theory. Okay, and that forms the basis for your databases. So maybe in some other session we'll talk more about it. But that is all from my end. I hope you all enjoyed it. Thank you so much for listening. Thank you so much for joining. See you in another session. Bye bye.